Yeah, so it'll be recorded. So if you want to check it in afterwards. So are you guys all located on the west side?
Yeah, we're all over in Sacramento.
Are you guys supposed to get a lot of rain this week?
Yeah.
Brian, you made it all the way out to Bishop over the weekend?
Yeah, Nate and I went out there, and then Friday night we spent the night at Buckeye. It was 11 degrees when we woke up, and then
the photo you sent, I was like, okay, well, you went out to the Bristlecone Pine Forest. So
yeah, that was I haven't been out there, and that was cool. Yeah, so we went out there, and then there was chain control from Myers, from South Lake Tahoe all the way to Placerville last night. So cars spinning off the road, people not knowing how to drive. It was great. It was very tiring, exhausting.
No fun.
I just got off a call with a few others and a couple of the weather service, and they're saying like even in Redding they're expecting like maybe 8 to 10 inches of snow in Redding.
Wow.
So cold.
Yeah.
Well, cool. Well, I'm gonna go ahead and mute myself. So.
Okay. Is this probably everyone that we'll get here? I think I went.
Yeah, we might have a few others maybe hop on, but go ahead and start.
Okay, great. Well, hello everyone. My name is Josh Feinberg. I'm the lead avalanche forecaster with the Eastern Sierra Avalanche Center over here in Mammoth Lakes, California. And well, thanks for inviting me to give a little presentation on avalanche awareness. And I'll also give talk a little bit about what we are at Eastern Sierra Avalanche Center, a little season history from last year and what we've gotten so far this year. So maybe I'd like to first start out just with a brief introduction of folks. If people could just say who you are and what kind of exposure you might have to avalanche terrain, either in the past or you might foresee in the future. So if you want to, let's see, I'll just call people out. Brian, you want to start first?
Yeah, sure.
Right.
Oh, go ahead, Brian Murphy.
I see my name up there, so yes. So I've been a snow surveyor with the department for, I think, close to 10 years now. So a lot of experience with that. And prior to that, I did recreational backcountry skiing. So a lot of, reading terrain and then looking at the avalanche forecasts to determine what the rating's going to be and what the decisions are going to make that day. So yeah, I'm pretty familiar with figuring out what the weather's going to be like in the terrain and adjusting accordingly.
Right on. Where's most of your backcountry experience geographically?
Carson Pass area.
Okay.
Yeah.
Nice. Cool. Beautiful up there.
Yeah, I like it.
Other Brian?
Yeah, sorry. Just a few years doing snow surveys and then got into backcountry, I don't know, a couple of years ago, but nothing too extreme. Definitely good at the Abbey forecast and then had an Air One training class.
Nice. Nee, is that how you pronounce it?
Oh, yes. I'm just a student assistant, so I just joined here to listen to you guys. Nothing much.
Oh, right on. Well, welcome. Hope you can learn some stuff.
Thank you.
Sean? Oh, Sean? Okay. Al Miller?
Not too much experience, just been out on a few snow surveys so far.
When you're out on a snow survey, where are those usually take place? Are those in the backcountry very far? Or are they pretty close to the front country?
The ones I've done haven't been that far from from the freeway, basically. I know others go a lot further back in on skis, but the ones I've done have just been maybe a half-hour snowshoe out, something like that. Not too far.
All right, nice. Rick?
Unmute. Yes, I have about the same amount of experience helping with the snow survey as Brian Murphy. I've been with the department since 2001 and came over to Flood in 2007. At the end of college, I got into snow camping. So like hiking around in the Trinities and in the Northern Sierra, kind of by the Carson Pass area, has been my experience.
Great. I love the Trinity Alps up there. That's a little gem. Nick?
Yeah, just mostly doing snow surveys, skied in with the guys before, and then done a couple helicopter trips. But beyond that, I don't really have any recreational experience.
Sounds good. Ramesh?
Yeah, I have been to this program since last year, and last year I had some experience going into the field and doing some snow survey, such as in Castle Creek, and this year we went to like Lake Audrey, Echo Summit, and we're planning to head out like this week and next week. Other than like using snowshoes and going and walking like almost half an hour to 45 minutes, I do not have any experience on skiing, but it is quite fun, going to the field and doing snow surveys. So that's what I like it.
Great. Well, thank you.
Thanks.
Nate?
Hi, I have been doing snow surveys for less time than Brian Murphy and Rick, maybe about 5 years or so. I generally go on the longer ones. We have ones that are like this coming survey. We'll probably have to park on Highway 50 and then hike for 3 or 4 hours, 3 hours or so to get into some of the surveys. I have some backcountry and front country ski experience. I've gone on a couple of like guided backcountry ski trips. And I've taken like most of us that do the surveys for a while, we've taken the Abbey 1 course a few years ago, but it's definitely good to have a refresher on some of the resources and some reminders on things.
Terrific. King JJ.
John, you're still muted.
Hi, I'm John. I think I've done about 12 years worth of surveys, probably more, maybe 15. Most of the surveys I have done have been Highway 50 and Highway 80. Longest trek is maybe 4 miles one way and then 4 miles back. Minimal recreational skiing or touring other than the snow surveys. Now we actually have a setup that is very conducive for touring, so maybe I'll get out and do more. But that's my experience.
Terrific. Well, thank you all for sharing. Did I miss anybody? All right. Well, sounds like we have a quite an array of different experience out there. So hopefully some this will be completely new stuff, and others this will be a good refresher. So I'll kick it off here. If anyone has any questions at any time, feel free to just unmute yourself and ask me. With only 10 of us here, or 11 of us here, I think we can do that pretty easily. So I'll share my screen here, and we'll get going. Okay, everyone can see that okay, hopefully.
Yep.
All right. So as I said, I'm with the Eastern Sierra Avalanche Center. We're let's see here. We're a nonprofit organization here. We're based in Mammoth Lakes, and we cover basically Virginia Lakes to the north, all the way down to Bishop Creek in the south. So it's quite a range of mountains, all accessible from the east side. We have 9 people on our board of directors. They do lots of work to get us funding and give us direction on our organization. But we're 3 paid forecasters that do the grunt of the work here. It's myself, Chris Engelhart, and Steve Mace. And we actually just hired 2 other part-time staff to help with grants and some educational outreach. And we also have a lot of volunteer observers. We're always extremely grateful for people getting out there in the mountains and giving us, submitting their observations about what they see out there, because it's such a wide range of area that's really helpful for us. Our mission is to inform and educate the public on avalanche conditions in the backcountry of the Eastern Sierra Nevada of California. So that can be done through predominantly our website, our esavalanche.org. We do daily advisories for the bulk of the season. And so this is just an example of one of the pages, the bottom line. Then we have things broken down into what avalanche problems are concerning, and some discussions and weather information. We'd also do a bunch of education and community outreach. So this is an example of some of that. We also give a presentation to the Mono County and Inyo County search and rescue teams. We collaborate a lot with Mammoth and June Mountain ski patrols. We get a lot of information on what they get in terms of snowfall and avalanche conditions, which is really helpful for us. And then we also have signs and beacon checkers in various areas in our region out here. These are some of the partners that support us. Very grateful for all of that. And yeah, as I said, we're a nonprofit, and so we really rely on grants and donations to survive. So we covered this already. Thank you all for sharing. So I'll start off with just giving a brief overview of last 2019-2020 season history. After that, I'll get into more of an avalanche 101, what it takes to have avalanches, what kind of avalanches we see, and then I'll get into this season. So this is a season chart starting with November. And so I'll start off with basically last year. Thanksgiving was a terrific start to our season. We had over 5 inches of snow water equivalent, which is almost over 57 inches of actual snow on the ground around Thanksgiving time, which is a great start for us. We didn't have any snow on the ground, and then all of a sudden it just dumped, and we were off to a really great start. A lot of excitement and enthusiasm. Then we had mid-December came along, and we had this warm, wet storm that came through and rained up to almost 10,000 feet and left us an ice crust up high, which is not so ideal. And then as the season went on, we had a big period of winds. Winds were just nuking all over the place. Eastern Sierra is notorious for really high winds, really affects the snow surfaces, build wind slabs for avalanche concerns. But it went on continuously for such a long period that avalanche concerns really diminished, and it was more just eroding our snow surfaces and making it tough to travel. Then we started having this concern over this November snow that fell, and quite a bit of time without snowfall, that the lower layers of the snowpack started faceting, and it gave us some concern over deeper instability. And that happened towards the end of December. If you can see this picture on the left, it's a magnifying glass showing snow crystals, how you can see they're kind of angulated. There's some striations, and that kind of, those crystals don't bond very well. And so when we see that in our snowpack, they're kind of loose and sugary, and that's concerning. This is a snow profile on the right, where you can see this. This is basically how dense the snow. The further left these graphs go, the more dense the snow is. And so you can see this layer right here is a very low density layer, and now it's composed of these faceted crystals, which, more dense snow on top of low dense snow is a bad recipe for avalanches. Then we had this huge dry period from middle of January all the way to the beginning of March, essentially, which was lots of low danger days, not what we want to see in terms of avalanche forecasting, it's safe. So in that sense, it's good. But we definitely want people are out there in the mountains to enjoy snow and soft snow. And so that was a tricky period of time. We had 26 days in a row of low danger, which is fairly unheard of for us. And we were getting close to that just now. But looks like in the next couple of days, that's going to all change for us this year. Then came the March. It finally started snowing again, which we were excited to see. And then March 15th came. And for us, that was, and for us in the world, essentially, that was the coronavirus, and that affected our operations tremendously. Mammoth Mountains, June Mountains, their lift service, they've all shut down. And things turned upside down for snow world and every other parts of the world. Of course, right after it shut down is when winter finally really turned on. We kept forecasting through the end of March with lots of discussions about whether we should be, whether is that encouraging people to get out in the backcountry, or is the information we're providing for people who are getting out there valuable and keep people safe. But we had these big storms in the end of March, and this, if you can see, this is a people counter going up one of our popular access areas called the Sherwins, and this is how many people per day go through these gates to get to a popular area. And right after that shutdown happened, and then after that snowfall happened, it spiked over 200 people a day for several days, which is tremendous because the lift service was shut down. So people were getting on the backcountry that really had no clue and much experience about what they're doing out there, except that they knew how to go hike up the back of a hillside and get some snow. So we were really worried about potential danger, avalanche accidents happening. But fortunately, that snow came in fairly stable. And even though it was a lot of snow, it came in right side up, meaning more dense snow at the beginning and less dense snow at the end. And fortunately, we didn't have any accidents. Then it kept snowing after that. We had these more storms towards the end of March. And then finally, April 1st came around for us, and we suspended our operations, basically abiding by the local authorities' requests to limit people's risk in the backcountry. And so that was a tough decision for us, but one we felt was the responsible thing to do. Then, of course, beginning of April, and one of the biggest storms of the year happened. 5.2 inches of snow water equivalent and over 52 inches of snow in just a few days there. So a lot of people were just standing by inside, staying at home and watching this happen outside. It was a tough situation for a lot of folks. That being said, that was also the biggest avalanche cycle of the year we had. This is a natural avalanche outside of Bishop. It's not that great a picture, but you can see the crown that just went across this whole slope, thousands of feet. And then finally on April 11th, we had our first avalanche incident of the year. And this was Paiute Crags outside of Bishop. You can see up here, there's a snowboard line that comes down through this slope here, and then it converges over here. And then right around here, the person triggered this avalanche that ripped out above him and flushed him all the way out through this terrain and buried him up to his neck. He was very fortunate that his friend was nearby, not down below actually, and was able to get over to him and dig him out. And he was able to walk out with just some bruises and a broken and a half snowboard. But this is some pretty extreme terrain, and very fortunate that that was the outcome for that. Social media response wasn't so nice after that. There was a lot of criticism and comments like, should just leave his body out there and get it in the summer if he had actually gotten buried. So that was another just facet of that we had to deal with in terms of we really want to encourage people to submit their observations, and everyone a lot of people make mistakes, and we want to be able to learn from that, and for people to share their experiences and not be criticized for errors in their judgment. Then towards the middle of March, it heated up a lot. We had a wet avalanche cycle that was pretty significant. Lots of wet slides happening. Fortunately, no one was caught. It was just people were seeing them hiking around the lake, and the snow above them on the other side of the lake, getting warm, would slide down. We had some good videos from people that filmed these events. And then finally, towards end of November, we had our second avalanche incident of the year, rather. This is Independence Peak, outside of Big Pine. And there's a couple hiking up this gully on a really warm day. The overnight refreeze was not very substantial, and they were up in this zone up here, off to the side, switching over from skis, putting their skis in their backpack in order to continue hiking up this gully when this avalanche ripped out above them. And the one person was on the side enough that he wasn't taken, but the other person was swept down most of the way and ended up breaking her back, and a helicopter was needed for an evacuation. So this is some precipitation averages for one of the wettest years, driest years in average, and here was us in the red last year. So we stayed quite below average up and through May, and that was our season. Is there any questions so far? And I'm kind of going through this kind of quickly. All right. So these are danger ratings last year by season, and the season before and the season before. Usually this is kind of normal for us to have, green down here and a lot of days of moderate and then considerable and high. And then last year, this is just a tremendous amount of low danger days. We haven't seen that in a long time. And we were worried about it this season, but hopefully that'll again change in a few days. So that's the first part presentation here. And now for more of the avalanche awareness, what are avalanches and what goes into them? First of all, about 36 people a year will die in North America from avalanches. So that's a significant amount, and worldwide it's closer to almost 200 people. So this is something we want to learn about so we can avoid dying in an avalanche if at all possible. To have an avalanche, you need three things. You need avalanche terrain, slope that's steep enough to slide or below a slope. You need unstable snow. So, if you don't have unstable snow, there's not much of a concern, or if the slope is dry without snow. And then you need some sort of trigger, whether that be natural or whether it be human. So terrain-wise, the most important thing you need is the slope. And this is a measurement of what slope angles are and where avalanches are most likely to occur. So right in the zone between 35 and 40 degrees is the most dangerous zone for avalanches to occur in. But avalanches definitely can occur on slopes as low as 30 degrees or even lower as 25 degrees in some extreme conditions. But typically between 30 and 45 that's when you're in avalanche terrain. Steeper than 45 slopes are just too steep to really build up snow. They tend to flush out and slough more often, and so they don't build up as much as lower angle slopes. So being on a slope is obvious if it's a steep slope, but being underneath the slope is not so obvious sometimes. Here's a map showing Highway 395. Just south of Mammoth, just north of McGee Creek. And this is actually McGee Mountain, if anyone is familiar with that. And this part of 395 had some houses under here. And a few years ago, there was actually a big snow and wind event that caused an avalanche to rip out up here and go all the way down and hit this house here. It didn't quite hit the highway, but it hit the house and buried the bottom part of the house. And there's actually a couple with a newborn kid. But they were upstairs, fortunately, and they weren't hurt, but it was quite a scary close call. This blue, though, this blue line out here shows what the maximum possible run out of an avalanche could be. And this is, so it could actually cross the highway given in the most extreme conditions. We use the term alpha angle by basically if you're down here with an inclinometer and you're looking up at the top of the slope, if that angle that you're measuring from horizontal is 20 degrees or more, that's basically you're still in the zone of where an avalanche could possibly hit you under extreme conditions. Any questions up to here?
that analysis that you just provided, is that also a function of the snow load in addition to the angle?
Yeah, the alpha angle of 20 degrees.
Yeah.
Yeah, so that does vary. That's an average, given most, like, an average snow climate of average snow density. It basically, it's a maximum. So basically, it would be pretty rare for a snow event, an avalanche, to reach as far as that. That's basically the maximum. So if you're thinking about camping underneath a slope and for a period of time where it might be stormy, you might use that alpha angle to figure out, like, hey, I don't want to camp this close to that slope. I want to be further away. But in very sensitive snow climates, it might be slightly less, that angle, and in other ones, more maritime, it might be slightly more. So it's a guideline, but generally 20 degrees. If you're that angle or further away, if you're shooting up at the top of the slope, you can consider yourself fairly safe.
Right. But there's no accounting for the limitations of the snow loading or the distance.
Well, the angle kind of takes into consideration the distance.
Okay.
Because you're out here, let's say you're at the highway with the inclinometer shooting up to the top of the mountain, so you're getting that angle. And if that angle from horizontal measures 20 degrees or less, you can be fairly sure that you're far enough away for, like, an avalanche, given, like, the most extreme, heavy snow and wind, that it wouldn't hit you at that point. But closer, you might be in danger. Does that make sense?
Yeah, thanks.
Okay. Thanks for the question. So along with terrain, another issue we come into is terrain traps. So, like, we think of big, huge slopes as dangerous for avalanches, but even small slopes can be dangerous if they end up in a gully like these people are in. This slope might only be 40 feet tall, but if an avalanche ripped out right above these people, it can bury them quite deeply if it's all entrained into a gully. So terrain traps is something that you want to be very aware of if you're traveling, even in seemingly benign terrain. If the avalanche conditions are high, they can still be dangerous. So you want to avoid gullies and go up around them, up over the hilltops, and just avoid those spots where you can be buried deeply, even with a small amount of snow. Here's just a movie depicting a period of winter where snow falls, accumulates, the wind blows, it goes away, then a weak layer might be put in there, and then it just shows you traveling on top, and all you see is the surface, but there could be a lot going on underneath the surface. And that's why it's important to check out the avalanche forecast and to take your shovel out and dig and look at these layers yourself for where you're traveling. These are the main avalanche types that we're mostly concerned of here in the Eastern Sierra and in most places. We have wind slabs, storm slabs, persistent slabs, loose wet, and then wet avalanches, wet slabs. I'll go through each one of these to explain them a little better. A storm slab is basically a soft, cohesive layer of snow that forms without wind effects. So think of this as more in, like, sheltered areas and trees, or in rare days up in the mountains up higher exposed areas when there's actually no wind. It's really rare for us in the Sierra to have snowfall without wind, but it occasionally happens. So basically, this is where the new snow, let's say it snows 1.5 feet overnight without much wind in an area or sheltered from the wind, that 1.5 feet of snow, if it avalanched on top of the old snow, that would be a storm slab. And these typically stabilize within a few hours or a couple of days. So these will be dangerous as it's falling shortly after, but then they'll usually stabilize unless there's some sort of strange weak layer underneath them within a day or two. And this is an example of a storm slab that's quite sensitive. This is skiing on one of the mountains out of Mammoth, and you can see how sensitive this snow is here, and not much wind effect, but it was all just laid down, and just cruising across it, all the snow just flushes out. And so this is me skiing across this area, and I was pretty intentional. I had a good idea that this would happen given the snow conditions, and so I was just around the very top of the slope. If I was halfway down the slope doing this, it's called ski cutting, that would possibly release the snow above me and flush me away. So something you want to be really careful of doing is you're at the very top of a slope, and and yeah, it takes, you know, we do it ski patrolling quite often. And it's a good test for us around the mountains in safe areas. Wind slabs are the most concerning avalanche problem that we have in a lot of places, but especially here in the Sierra. Winds can really change the whole snowpack in a matter of a couple of hours, from what is totally maybe a safe area to very dangerous. Winds will blow from one side of the mountains over to the other, and so the windward side, where the wind's blowing from, it'll be stripping snow, and that'll be a relatively safe area in terms of avalanches. But where it's depositing on the other side, the leeward side, snow can deposit, you know, feet, you know, multiple feet within a couple of hours if the snow and wind conditions are right. So things can change quite quickly with wind. So you almost want to, you know, pay attention to wind just as much as you do actual snowfall. So this is a picture on Mammoth Mountain looking over towards the Dragon's Tail, if anyone's familiar with that. But you can see it's blue sky day, no snow falling, but just the winds are just making the snow billow over this slope, and it's just depositing on this other slope here way faster than it could fall out of the sky. So this is quite obvious wind loading. You see that. It doesn't take a genius to figure out like, that might be something else going on there. But on lesser obvious days where the snow is just you know, going over the surface a little less obviously, a little more gently, it can still build up slabs pretty quickly. Here's a test we do a lot. Is I call it a hand pit test, where you separate out a column of snow to see how sensitive it is. And you can see that I was just separating it, and it actually failed and popped off. A lot of times you can cut out a square of snow if you're concerned about the upper layer of wind slab. And then you can put your hand behind it and see how much force it takes to pop that off. As you can see, when it just pops off like that without even pushing on it, that's a heads up that there might be some pretty unstable snow out there. This is somewhere in South America. I'm not sure about the outcome of this avalanche, but this is just to depict a wind slab, you know, blue sky day after some fresh snowfall with some winds over the ridge, about what can happen. The next avalanche type we have is a persistent slab avalanche, and these are a bit more complicated. This is where you need a weak layer underneath the snow. And sometimes that's surface hoar, which is these little feathery crystals that form kind of like the wintertime equivalent of dew, where moisture accumulates on the ground and forms these really beautiful looking feathery crystals. But if that stays intact and then it snows on top of that, it's like very weak, just, you know, snow being held up by just like feathers, essentially. A little bit of force the wrong way can topple the whole slope. We don't see these too often in the Eastern Sierra. We do sometimes, but in the Rockies, they see this a lot more. And in fact, in the Sierra Avalanche Center up in Tahoe, they have this as their leading concern today because of some surface hoar that formed up there and persisted. So we'll see today if there's any kind of activity, or hopefully not any incidents. So this is what surface hoar looks like, these feathery crystals, like they grow like that. And then snow falls and covers them up, and they're just these really fragile crystals underneath. And then you can be skiing, and then it can trigger a slope quite far away. You can trigger a failure way uphill or way across slope, you know, thousands of feet even sometimes if the conditions are right. And this is called faceted snow. This isn't the surface hoar. This is more snow that sits in the ground for a while. And as snow sits, it changes. And when there's not a lot of snow and the temperature changes quickly from the bottom of the snowpack to the top of the snowpack, that gradient, if it's a high gradient, it'll form faceted snow, which is these crystally shapes that don't bond well together. If it's a deeper snowpack and the temperature changes over a bigger space of time, they'll tend to form rounded crystals, which bond together and is much more stable. Continental snowpacks have this a lot, where there's just not as much moisture as the maritime that we are in. So they're dealing with this a lot, as opposed to here, it snows a bunch. And so oftentimes we get a deep snowpack fairly quickly. This season's been an exception. In the early season, we had some snowfall in November. And then it just sat there for a long time. So we did develop some of these facets, and we were worried about this. And I'll get into that with our season history shortly. Here's another test we do called an extended column test, where we isolate a 90 centimeter long by 30 centimeter tall column, and we tap on it and see what happens. That's not a result we want to see for a slope that we might be thinking about skiing. And as you can see here, there's like these loose facety crystals underneath this more dense snow. There's a handful of different snow pit tests that we do. This is, I think, one of the better ones. Not too hard to do, and it gives you a lot of information. Other ones we do is just a compression test where we would isolate just a smaller column of snow, basically your shovel width. And that gives you an idea of what could fail. But this one also gives you the added information of a crack propagating across the snow further. This is an example in 2015. This is Climax, the big main slope underneath the gondola on Mammoth Mountain. This occurred on December 23rd. We've done avalanche control work. People had skied this slope, and then someone skied it and hit a weak trigger spot, and the whole slope fractured. And one person was buried with just a finger above the snow, and the patroller was fortunate enough to find them and dig them out before too long. But the whole mountain shut down, and hundreds of people were involved in probing that whole area for the whole rest of the day. Again, really fortunate that we didn't have any fatalities from that. But that's, a weak faceted snow at the base of that was responsible for that avalanche. Loose wet avalanches are a different kind of avalanche that we worry about in the springtime or midwinter when the sun comes out and days warm up. This is basically just what it sounds like. Snow warms up and there's moisture in the pack, and then it releases, and it can release from like a small little point, and then it fans out and trains more snow. And so they can be pretty minor and small, like perhaps some of these, or they can really entrain a lot of snow, especially if they were in a gully. So these are things to think about during warming up periods, especially right after snowfall. If we have a decent sized snowfall and then it really warms up the next day, that's something that's can be really concerning for sure. Then more concerning than that is wet slab avalanches, where a whole slab of snow can release, where you might have a weak layer in the snowpack and then rain on snow. All this moisture going to the snowpack quickly can create some really large, massive avalanches that are quite destructive. This is the one where I'm looking at the crown of just outside of Mammoth again, in a place called Punta Bardini, where it probably released 600 feet across or so. And the crown that much, and the debris pile was maybe 20 feet tall at the bottom of the slope. And again, so that's something you really want to keep an eye out with rapidly increasing temperatures, and definitely rain on snow. So all these things affect how snowpack is: the wind, the sun, and the rain. And basically, this is a topographic picture of a mountain. And so if the winds are going from one direction, one side of the mountain might be totally safe, while the other side is getting loaded and dangerous. And again, how the sun affects it in terms of aspect, like the southerly slopes might be getting hit by the sun hard and warming up, by the northerlies are staying cold and dry. So you just want to really take into consideration what aspect of the terrain you're on and how that is affected by things like wind and sun. Finally, the last thing you need for an avalanche is a trigger. And there's natural triggers. Rapid snow loading is one that's probably the most common cause of avalanches, whether that's just snow falling straight out of the sky or more commonly combined with wind. So snow falling at a high rate and the wind blowing on top of that can really create massive loads of snow quickly. And that triggers most of the avalanches that occur. Warming, like I talked about, sunshine or warm days or rain on snow. Even sometimes clouds can do this as well. Like if it's clouds can actually trap the heat in. And so even on north facing slopes, sometimes you'll see after cold snowfall, if it comes in, a warm cloud layer comes in, that can create some warming and instabilities as well. And a cornice failure. The cornices are these big whale-like features that build on top of ridges from the wind. And if one of those builds and overhangs and fails, that can fall down and trigger an avalanche underneath it. But the ones we are mostly concerned with are the ones that we humans trigger. And avalanches can occur all they want. If no one's around, they're cool things to look at. But if someone's trapped in it, then it can be a tragic, it can have very tragic outcomes. So 90% of avalanches avalanche accidents, the victim is, or someone in the victim's party is actually the trigger. So they don't just happen as a random act of nature typically when humans are involved. So red flags, these are the things that if any of these happen, the spidey senses should be tingling and giving you second thoughts about where you're going and making sure you know where to go that's safe. So first of all, recent snow load, like we talked about. If you see recent avalanche activity, if you actually see avalanches, crowns from recent hours or in the last day, that's a good indication that the snow might still be unstable. The recent winds, like you're seeing wind blowing over the ridges, that's definitely an indication that it might be depositing and forming dangerous wind slabs. If you're traveling along and you see collapsing, like the actual snowpack settling, and you can actually sometimes hear that, or you can actually see trees off in the distance, branches wave around because the whole snowpack actually settled. That's called a WUMP also. And that's an indication that a weak layer underneath the snow failed. And if you were on a steep enough slope, that probably would have avalanched. Cracks that shoot out from your skis far, that's another indication that there's some instability in the snow. And then rapid warming. And I have a couple of examples of all these things here. So yeah, if you wake up in the morning and this much snow is on your roof, avalanche conditions are probably pretty high. You see an avalanche like this, you probably wouldn't want to go ski a slope that has a similar aspect of a similar elevation as this one if you just saw this happen on this slope. Blowing winds again, that gets me every time seeing winds blowing. I've been involved in some avalanches from wind loading that have had some tragic outcomes, and it's something that I'm ultra aware of. You can see this crack shooting out from the ski tip going across the slope way out here. If this slope was a steeper slope, that probably would have avalanched. Then rapid warming. Sunshine comes out after a cold spell. Those first couple days of sunshine coming out are the most concerning. So I know I kind of covered things rather quickly there, but does anyone have any questions on what I just covered? All right. So I really want to encourage people, if it sounds like a lot of you do have ARI 1 courses under your belt, that's great. I think training is the best thing to have if you can take a course, but there's also some great books out there. One is called Snow Sense by Jill Fredstone. It's a great almost pocket-sized book that is a great introductory book into avalanche problems. If you want to get more into the nitty-gritty, Bruce Chemper has a book called Staying Alive in Avalanche Terrain, and that's a pretty intense read, but there's it's almost a reference manual. There's some great information in there, but there's lots of information sources, and getting out with a mentor, someone who has more experience than you to start off with, is also a great way to learn about avalanche conditions. All right, everyone hanging in there. One last presentation about this year, and then we'll be wrapping it up. So 2021, our season so far, and hopefully it's far from over. It started off this year with 2 snowstorms, one at the beginning of November and one at the middle of November. It almost dropped 3 inches of water, 21 inches of snow. This is pretty exciting. It's like, oh, wow, great, some early snowfall. Unfortunately, it just snowed those times and then it didn't snow much for a while. In December, for the whole month, we had almost 35 inches of snow, but spread out over a whole month, that really isn't much for us. And what happened is the snow started sitting around from November and faceting, like I was talking about. These crystals here, you can see these angled edges, these striations. Basically, it was a really weak snowpack underneath this December snow that we were started to be concerned about. These are the snow pits we were digging, and they were showing these really weak lower layers. And this little stout layer in the middle, that was basically separating the early November storm to the mid-November storm. And these low density areas were these faceted sugary crystals. And tests were failing consistently, but we just didn't have that much snow on top, so we didn't see any actual avalanches occurring. But it was something we were monitoring and tracking and talking about, always worried about for quite a while, but they didn't occur. Mostly didn't occur. There was one avalanche that we saw up in Virginia Lakes that happened here naturally during the loading event. And here's a picture depicting, you can see the difference in density here in this picture of this weak snow underneath. And here's a video, it's about a minute or so long. This is Steve Mace, one of our other forecasters, and he's going to go through a couple different snow pit tests that we do and talking about this facet layer that we were worried about.
Hey Josh, just a heads up, I don't hear any sound.
Oh, for real? Oh no. Thanks for letting me know. Let's see here. Okay, well, I'll narrate. So he basically extended it, dug out a column there, and he was tapped on the shovel to see what kind of reaction happened, and he's showing you the weak faceted grains there. This is a propagation salt test, which is a little different. It's like a longer column upslope instead of a cross slope. And this is to basically target a specific weak layer, and you run this saw up along that weak layer that you're worried about. And if it doesn't go very far up the slope before it fails, it's settled there. If you can see, it's concerning. So if you only went up that far, that's not so good. If he gets up all the way to the end of the column before it fails, that's more stable. So that's another test that we use. And you can see those sugary, large faceted crystals that we're worrisome. He's doing the same thing again this time, but he's putting actually some more snow on top to see what happens. Like, let's say it snows another 4 or 5 inches, and how would that affect the result of this? So it's basically simulating a snowfall with our snowpack. So let's see how far the saw gets up when he runs it along this weak layer this time. Ooh, barely any. So that's basically showing how, you know, a snowpack might be more stable before it gets more load. So right now we have a situation where, let's see, we have a situation where we still have these faceted layers underneath the snowpack. They've been strengthening somewhat in some places, but in other places they're just weak and sugary still. But we just don't have the snow on top to be concerning for an avalanche. But come Wednesday, when it starts dumping, that might be a different story. So what we weren't worried about might become very worrisome. So January, so we stopped talking about that persistent slab, and we just had the wind stripping our mountains essentially. We had a small little storm beginning of January, 1 to 3 inches or so, less than half an inch of water. Then we had this big, huge period of springtime for us, almost 3 weeks of warm temps. So we were out in our t-shirt. January 19th, we have a little trace of snow. And then just recently, a few days ago, we had 2 to 4 inches of light snow, and we just had another 5 inches of really light snow overnight in Mammoth. And we're supposed to get maybe 1 inch or 2. We'll see what happens. And tomorrow the sunshine should come out. But then after tomorrow, basically finally what we've been waiting for all season is a real snowfall. And this is what the moisture chart is looking like for the 6-day outlook from starting yesterday until next weekend. So we're looking at like this red mammoth is right here. So I know you guys are in Sacramento, not quite in the mountains, but this whole red band is, it's close to 7 inches of water, and these lighter pink bands are even 9 inches or maybe even 10 inches of water for the 6-day outlook. So we're quite excited. Hopefully people will stay smart and out of harm's way while the snow dumps. We're expecting some large natural avalanche cycles to occur, even without this weak layer that we're worried about, this November facet layer under here. There's going to be some big avalanches come through if as much moisture falls as they're saying is potentially possible. But all this new snow could also reactivate some of these deeper facet layers and result in even bigger avalanches. So it will be an interesting week coming up, and we're excited about it. And again, hopefully people will be smart and stay safe. Any questions from any of that I just covered? I know I went through pretty quickly, but yeah, thanks for your attention.
Yeah, thanks, Josh. That was a good overview, just what to look for, and thanks for going over this season's snowpack as well. That really helps. Yeah, and just a reminder that we don't use the ESAC page too much because we don't spend down there, but the Sierra Avalanche page for sure, and then just being aware of the aspects and what we're going. So thanks for that great overview. I really appreciate it.
My pleasure, and thanks everyone for your attention. And yeah, the Sierra Avalanche Center does a great job forecasting those mountains up there. They've had a more persistent concern than we did this season. They actually had quite a lot of avalanches failing on that persistent layer. They had more snowfall, bigger slabs on top of there. So that they'll be watching that layer as well in the coming days coming up. So yeah, fingers crossed it doesn't fizzle out like some past forecasts have. Yeah, thanks again for having me, and I'll share this recording. I'll send it to Brian and Sean to share with you guys. If you want to share it with anyone else, feel free. Yeah, great. Well, thanks very much.
All right, thank you. I appreciate it too.
Yeah, thank you, Josh.
That was a great presentation. Thanks.
Thank you so much, Josh.
My pleasure. Good luck with the snow surveys.
All right.
Thanks.
All right. Take care.
All right, you too.
Bye.
All right.